Alright, this is part 2 of the video going over the exam 4 review. So on number 17, this is one of those rectangle problems we did. We've got an area of 36 square meters. It says the length is 5 meters more than the width. We know that the area of a rectangle is length times width. It says the length is, actually I'm sorry, I'm going to make a rectangle here, and we normally let the width be the shorter length. It normally will be with these problems. So notice it says the length is 5 meters more than the width. So you could write that as L equals W plus 5. That would be 5 more than the width. The length is 5 more than the width. Remember, is means equals. So instead of using L for the length, we're going to use W plus 5. So if the width were 10, then the length would be 15, 5 more than that. So now we know length times width is 36. And so we have W times W plus 5 equals 36. We've got to distribute and then subtract 36 on both sides. This is a quadratic equation, so we're trying to get 0 on one side. Alright, so now we're going to use the AC method. We need two numbers that multiply to negative 36 and add to 5. That's going to be 9 and 4. We need to make the 4 negative. And we can take the shortcut here. We get W minus 4 times W plus 9 equals 0. And so W is going to be 4 and negative 9. Now we know width can't be negative, so we got to throw that one out. So our width is 4, and we're working with meters here. And we know to find the length, we know that it's 5 more than the width, so 4 plus 5, that's 9, so we get 9, and we're working with meters here, so 9 meters. So if you didn't already try 18, you might want to try 18. It's very similar to what we just did on 17. And then you can watch the video. Alright, so notice here the length is 3 inches less than twice the width. So we would write that as L equals 2W minus 3. Twice the width is 2W. And if you want 3 less than that, you have to subtract off 3. So when we make a rectangle, our width is W, that's our shorter side, and the length is 2W minus 3. So again, the length times the width should be 54 here. We're going to get 2W squared minus 3W when we distribute on the left. And then we need to subtract 54. We know again with quadratic equations, we got to get 0 on one side. This is certainly a quadratic equation because of the W squared. So notice AC here is negative 108 and B is negative 3. So you may have to get on the calculator to find the numbers that work here. It's going to be 9 and 12. And we do need to make one of those negative. It's going to be negative 12. Alright, so let's see. We've got split this into 2W squared plus 9W minus 12W minus 54 and factor by grouping. Notice W is the only thing we can factor by those first two terms. And again, when we factor the second two terms, we should expect a 2W plus 9. So 2W times negative 6 will give us that negative 12W. And so we're going to end up with 2W plus 9 times W minus 6 equals 0. So you can see that the width is 6. Now if you solve the other equation, you actually get negative 9 over 2 if you set 2W plus 9 equal to 0. But we know we can't be negative when we're talking about a width. And so the width is 6. We're dealing with inches here. To find the length, we're going to have to plug that in to 2W minus 3. Since our width is 6, so that's 12 minus 3, which is 9. So our length is 9 inches. By the way, on either of these problems, you can easily check them. Notice 6 times 9 is 54. And 9 is 2 times 6, or 2 times the width minus 3, so very easy to check that. Alright, let's move on to number 19. So now we're talking about radicals. If you look at letter A here, square root of negative 49 equals negative 7. We actually know that's not a real number. You can't take the square root of a negative, so that's certainly false. In fact, the smallest number we can take the square root of is 0. The square root of 0 would be 0, but we can't take the square root of a negative number. At least we don't get a real number. We certainly don't get negative 7. Now in letter B here, we know that we can only have like radicals. Oops, I went the wrong way here. Let's do D. That one's false because square root of x times square root of x should equal x. Now, if this had said the square root of x squared, that would equal x. But that's not what it says. So that one's false. We should have gotten x there. Now let's move to B. Going a little out of order here. So these aren't like radicals, so that's not going to be true. That's false. Letter E, notice we square the x minus 5 and then take the square root of that. So those are opposites. So we're just going to get the x minus 5. That is true. Now if you look at C, we know that when we multiply radicals, we can only multiply radicals that have the same root. These are both square roots, and in fact that is how we multiply radicals. So if we had like square root of 3 times square root of 5, that would be the square root of 15. And so that's true. That is how we multiply radicals. On letter F, 7 to the 1/2 power, you should recall, means the square root of 7. And if you take the square root of 7 on your calculator, you don't get 3.5. It's something a little bit different than that. If you actually multiplied 1/2 times 7, you would get 3.5, but that's the wrong thing to do. So this one is false. On letter G, it says to add radicals, you must have the same root and radicand. And that's true. We call those like radicals. To multiply radicals, you must have the same radicand. Well, that's not true. We said you have to have the same root. Now, before we do number 20, we talked about a relationship between fractions as exponents, or rational exponents, and radicals. So there's a property, it says a to the 1 over n power is the nth root of a. And a to the m over n power we can write as the nth root of a to the n power, or the nth root of a all to the n power. Notice in each of these problems, though, the denominator gives you the root. So you got to be careful that you don't get that confused. And then the numerator can either be put inside the radical or on the outside of the radical. So in number 20, we got x to the 3/5 power. That's going to be a 5th root. And we can put the 3 inside or outside. I'm going to put it inside on this one, but it doesn't really matter. A to the 1/4 power, that's going to be a 4th root of a. On 21, square root of 10, square roots are a special case. We talked about how anything to the 1/2 power is a square root. We could write a 2 here, but we normally don't. And so anything to the 1/2 power is equal to a square root. So this is 10 to the 1/2 power. And then for B, notice our radicand, the 3x, becomes our base. So it'll be 3x to the 1/4 power. You do need the parentheses there, because the 1/4 goes with the 3 and the x, not just the x. Number 22, we're going to have the square root of 16, which is 4. On letter B, this is going to be a cube root. By the way, notice we are evaluating here. So in each of these problems, we should end up with a final number. So be careful when you take the test that you go all the way and get an answer that's a number. On B here, this is going to be a cube root of negative 125. So we're looking for something you cube to get negative 125. And that's going to be negative 5. letter C here, this is going to be a cube root of 8. Now I could put the 2 inside with the 8, but I'm going to put it outside. Cube root of 8 is 2, but don't forget we got to square that number, and so this is going to be 4. So you might try letter D if you want to try it, and then watch the video. Alright, so this is a 4th root of 16, and that's going to be cubed. Notice we wouldn't want to cube 16 and then take the 4th root of that. It's much easier to cube, put the 3 on the outside. 4th root of 16, some number to the 4th power is 16. That would be 2. And don't forget we got to cube that, and so we get 8. Alright, let's move on to number 23. So now things are kind of mixed up, and we need to see if you can work with radicals correctly. So let's go ahead and look at these problems here. We know on letter A here, this is how we multiply radicals. As long as they're both square roots, we can multiply the 3 with the 7, we get square root of 21. For B, we can't add radicals unless they're like radicals, and those are certainly not. So that's an expression that's already simplified. Notice on C, we have 8 square roots of 2 plus the square root of 2. Now this is understood to be 1 square root of 2. So 8 and 1, we're going to get 9 square roots of 2. So 8 square roots of 2 plus 1 square root of 2 make 9 square roots of 2. Remember what I said in class, it's just like adding 8x plus x, just like adding like terms. Very similar. Alright, let's move on to D. Notice I can't multiply the square root of 10 by anything but another square root. And so this one's simplified. On letter E, we've got 3 radical terms, but only 2 of them are like terms. So we can add those 2 together, but the other 2 terms aren't going to change. So we'll get 5 minus, let's see, negative 6 and 4 gives you negative 2 square roots of 3. And then don't forget the plus square root of 6. Now be careful on letter F. This 2 here goes with the square root of 5. It's 6 minus 2 square roots of 5. So we have a radical term, and we have a constant of 6. We cannot add, or we cannot subtract here. That 2 is connected to the radical. So we can only add a rad 5 with another rad 5, so we're done. This is simplified. Now letter G, this is 3 times the square root of 7, multiplied times negative 5, so it's all multiplication. We can multiply the negative 5 with the 3, let's go ahead and do that. But that's the only thing we can do. We could only multiply a square root of 7 times some other square root. So we're done here. Now letter H is one of our special cases. You could say square root of 25, but that would be 5. But we learned that anytime you multiply a square root times itself, you get the number inside, the radicand. It's maybe easier to see it if you write square root of 5 times square root of 5 as square root of 5 squared. And we know when you square a square root, those are opposites, and so we just get the number inside the 5. Notice on letter I we have some like radicals, so we can take 3 minus 8, we get negative 5 square roots of 14. Notice on J, it's kind of like letter H. We're multiplying a square root times the same square root. We're going to get x plus 2 here. Again, you could think of this as x plus 2, square root of x plus 2 quantity squared. And the radical and the 2, they are squaring and taking the square root, those cancel each other out there. And so you just get x plus 2. On letter K, we again have like radicals, so we can combine negative 5 and negative 2. So we get negative 7 square root of x. On letter L, very similar to what we did in J, you should get 5x here. On letter M, notice these are like radicals. They're both square roots, and they both have the same number under the radical. So 3 and a minus 1, we're going to get 2 square roots of x minus 6. And letter N, notice we're squaring a square root, so we're just going to get the 2x plus 9 there. Alright, let's move on to the next problem. So we have to simplify these radicals. First of all, we need to know our perfect squares, because there's a lot of square roots there. We also have a couple of cube roots. So again, we got to know our cubes. So on letter A there, that's square root of 64. What number squared gives you 64? That would be 8. And notice B, you could think of this as negative 1 times the square root of 144. So you're going to get a negative number. And of course, the square root of 144 is 12. So we get negative 12. On letter C, we're taking the square root of negative. That's not going to be a real number. Letter D, we're taking a cube root of negative 125. So what number cubed is negative 125? That's going to be negative 5. Now letter E, we could write as the cube root of 64 over the cube root of 27. The cube root of 64 is 4, and the cube root of 27 would be 3. So we get 4/3. Now on F through J here, these are not the square roots of perfect squares or cube roots. We learned that if the radicand, so that would be the 24 here, if it has a perfect square factor other than 1, so don't count the 1, that it's not considered a simplified radical. So we notice 24 is divisible by 4, so we can write this as the square root of 4 times the square root of 6. We know these two multiply to give you the square root of 24. So we're kind of going in reverse. We're breaking this down into two radicals that multiply to the square root of 24. The only thing is 4 is a perfect square, so we can take the square root of 4, we get 2. So our final answer is 2 square roots of 6. So on G, notice that 9 is a perfect square factor of 45. So we can break it into square root of 9 times square root of 5. And square root of 9 is 3, so we get 3 square roots of 5. Now if you look at number 10, there are no perfect square factors other than 1 that go into 10. And so this one's already simplified. On letter I, that's going to be a negative 1 times square root of 75. And notice 25 is a perfect square factor of 75. So we can break this into the square root of 25 times square root of 3. And that's going to be negative 5 square roots of 3. Now you got to be careful on letter J. You might think perhaps that it's 9 and 12. 9 does divide into 108, and 9 is a perfect square, but notice 12 also has a perfect square factor of 4. And so we need to find a bigger perfect square here. Turns out it's 36. 36 times 3 is 108, and so we get 6 square roots of 3. Alright, on 25, this one's a little bit tricky. Notice it's similar to this problem here, the square root of x plus 5 squared. And in that case, you'll get x plus 5 because you're squaring a square root. With 25, you've got two terms inside the parentheses there. And so this is really what I call foil in disguise. You're going to have to multiply two of these guys. And so x times x is x squared. X times the square root of 5, we're just going to put the x in front of the square root of 5. We got square root of 5 times x, so that'll be another x square root of 5. Now don't forget, 5 times 5, square root of 5 times square root of 5 is just 5. Now if you said square root of 25, that is 5, but you should get 5 there. So notice we do have some like terms here. A 1x and a 1x makes a 2x. So we get x squared plus 2x squared of 5 plus 5. Alright, on number 26, actually I think I'm going to go ahead and stop the video here, and I'll do one last video on the last 5 problems. So let's go ahead and do that.